Dear students, in this lecture video we are going to solve a problem on Otto cycle. So this is the problem statement. An engine of 250 millimeter bore, so this is the data for the cylinder diameter, and 375 millimeter stroke, this is the length, works on Otto cycle. The clearance volume is 0.00263 meter cube. The initial pressure and temperature, so these data are related to the pressure and temperature at point 1 bar and 50 degrees Celsius. If the maximum pressure is limited to 25 bar, so this is the pressure value at point 3. Find the pressure and temperature at all salient points, compression ratio, air standard efficiency of the cycle, and mean effective pressure. So let us solve the problem. So this is the PV diagram of an Otto cycle. So we all know that an Otto cycle consists of 4 processes. Okay, so 1 to 2 is adiabatic compression process, 2 to 3 constant volume heat addition process, 3 to 4 adiabatic expansion process, and 4 to 1 constant volume heat rejection process. Okay, so VC represents the clearance volume, so which is nothing but the volume at 2 and 3. Okay, then Vs is known as stroke volume or stroke volume. So the addition of these Vc and Vs give the value for the total cylinder volume, which is the volume at point 1 and point 4. Okay, so the given data are represented here. Cylinder diameter, so all values SI unit la I have converted at the beginning of the problem itself. So diameter D is 0.25 meter, length is 0.375 meter, clearance volume Vc is nothing but V2 and V3 is 0.00263 meter cube. P1 and T1 values are given, 1 into 10 power 5 Newton per meter square, because 1 bar is 10 power 5 Newton per meter square. Temperature value should be converted to Kelvin for the substitution in the formula. Maximum pressure value at point 3 is 25 bar, so that is 25 into 10 power 5 Newton per meter square. So enalla find out pannanom appadina at all the points pressure and temperature values. So at point 1 P1 and T1 values are directly given in the problem. At point 2 P2 value should be calculated as well as T2. At point 3 maximum pressure value is given, so T3 value has to be find out. Then at point 4 P4 and T4 values are to be calculated. Then in the second subdivision, compression ratio R, in the third part air standard efficiency eta, and in the fourth subdivision mean effective pressure PM values are asked to be calculated. Okay. So considering the process 1 to 2, that is adiabatic compression process, we know the PVT relations for the adiabatic compression process. So the relationship between the pressure and volume, or P1 by P2 is equal to V2 by V1 power gamma. Okay, so this relationship is for the isentropic process. So here we know the values of P1 and V2. Okay, so that values have been directly given in the problem. So we can calculate the value of V1, that is total cylinder volume, that is nothing but the addition of clearance volume and stroke volume. So the data have been given to calculate the stroke volume Vs as pi by 4 d square into L. So diameter and length of the stroke values are given in the problem. Just by directly substituting those values, we can calculate the stroke volume. In turn, the total cylinder volume, that is equal to V1 and V4, can be obtained. That is Vc 0.00263 problemthile irundhathu plus Vs stroke volume ipo calculate panna value. So the total cylinder volume has the V1 and V4 value. Okay, so now by applying these known values in the relationship P1 by P2 equal to V2 by V1 power gamma, here the only unknown value is P2, gamma value is 1.4, so we can get the value of P2 as 18.37897 bar. Okay, so this is the pressure value at point 2. Then to calculate the temperature value at point 2, we can use this relationship. T2 by T1 is equal to V1 by V2 power gamma minus 1. So here also the one and only unknown is T2. So just by substituting all the known values here, we can get the value of T2, that is the temperature at point 2, as 742.0602 Kelvin. So next, to calculate the temperature, that is the unknown temperature at point 3, we can use this relationship equation corresponding to the constant volume process. Because in Otto cycle, 2 to 3 is the constant volume heat addition process. So we can use this relationship. P2 by T2 is equal to P3 by T3. So here the one and only unknown is T3. So that value can be directly calculated as 1009.38739 Kelvin. Okay. So next, to calculate the pressure and temperature at point 4, we can use this relationship equation. 3 to 4 as the adiabatic expansion process. So for the isentropic process, the PV relationship equation is here. P4 by P3 is equal to V3 by V4 power gamma. P4 is the one and only unknown in this relationship equation. So that value can be calculated, 1.36024 bar. And the TV relationship for isentropic process is used here to calculate the temperature at point 4. Substitute all the known values and we can get the value of temperature at point 4 as 439.3661 Kelvin. So in the second subdivision of the problem, compression ratio value has been asked to calculate. So the formula for compression ratio is V1 by V2. The denotation is R. So we know the values of both V1 and V2. So substitute panna appadina, the compression ratio value can be obtained as 8. Next step, to find out the value of air standard efficiency eta. The formula for air standard efficiency eta for Otto cycle is 1 minus 1 by R power gamma minus 1, where R is the compression ratio. So substitute panna appadina, air standard efficiency value 56.47% அப்படின்னு கிடைக்கும். So next, it is asked to find out the mean effective pressure PM. The known formula is P1R into K minus 1 by gamma minus 1 into R power gamma minus 1 by R minus 1. So here K is the pressure ratio that can be calculated using this formula, P3 by P2. So the pressure ratio is 1.36 for the present case. Micha ella values may known values. So just by substituting all the known values and the PM formula, the value has been obtained as 1.3342 bar. So this is all about the problem. So the results are represented here. At point 2, pressure and temperature values. At point 3, temperature value. At point 4, pressure and temperature values. Compression ratio value or air standard efficiency eta is 0.5647, that is 56.47%, and mean effective pressure value 1.3342 bar. Thank you.